last time. Parallelogram law for addition and difference of two vectors, sum and difference. So in this, we saw that given two vectors A and B, we can construct what is called a vector parallelogram using a simple idea that when we want to construct vector parallelogram, क्या करते हैं, दोनों vectors को common origin से draw करते हैं. So both the vectors that we are considering, A and B, let's say, they are drawn from a common origin. And now they are used as adjacent sides of a parallelogram. So parallelogram को complete करने के लिए we draw two more sides which are parallel to A and B respectively, like this, and that completes our vector parallelogram. And then what we see in this parallelogram is that the diagonal that we draw from the origin, the common origin to the opposite vertex, वो diagonal क्या बन जाता है, sum बन जाता है दोनों vectors का. So the primary diagonal, और जो diagonal origin से लेके opposite vertex तक है, that diagonal now represents the resultant sum of the two vectors, and we denote this angle as alpha. And जो दूसरा diagonal है, suppose we draw it from the head of B to the head of A. So B से लेकर अगर A तक draw करेंगे, so it becomes A minus B. या इसके उल्टा अगर draw करें, that is A से लेकर B तक, then it would have become B minus A. So it depends on how we draw it. So here arrow कहाँ से जा रहा है, B से लेकर A तक जा रहा है, so it becomes A minus B. And this angle here is what we denote as beta. And of course, you have the same standard formula for A plus B and A minus B as you had for the triangle law. So there's nothing different over there. But this is just about the construction. So the related formulae are simple. They are the same as the formula you've seen before. A plus B का magnitude root of A square plus B square plus 2AB cos theta हो जाता है. And similarly, if it is E minus B, then यहाँ पे there will be a minus sign. That's all. That's the difference. Okay. And similarly, see here that alpha is tan inverse B sin theta upon A plus B cos theta, and beta is tan inverse B sin theta upon A minus B cos theta. So this is the simple thing. Okay. Now we had also seen special cases, and that was the important thing. So special cases of the vector parallelogram. So पहला case क्या था? It was the case where it's a rectangle. So rectangle के बारे में what was the important thing? If E is perpendicular to B, okay, then the parallelogram becomes a rectangle. Okay. And in that case, magnitude of A plus B becomes magnitude of A minus B becomes equal to root of A square plus B square, and alpha becomes equal to beta becomes tan inverse B by A. But I'll show you but the thing is, ये आपने last time लिखा है, so there's nothing new about this. These formulae you've written last time. It's just a recap. That's why you have these in your notes and you've written these formulae. Achha, I have not sent you the recording and the notes of lecture number 6 yet. I will send it to you because the recording is still getting uploaded. So I'll send 6 and 7 दोनों के notes एक साथ दे दूँगा, so you can go through this. Okay. So these formulae they are the same as the triangle law formulae. We discussed them in the last lecture. Okay, so then the special case number 2 that we had seen was the case of the rhombus. rhombus के केस में क्या होता है that magnitude of E is equal to magnitude of B. So in that case, the parallelogram becomes a rhombus, and then it has these important properties that E plus B is perpendicular to E minus B, and alpha is equal to theta by 2, and beta becomes 90 minus theta by 2. तो ये important special properties हो जाते हैं rhombus के. And then the third case was the square which overlaps these two. So square is nothing extraordinary. It's just E is perpendicular to B, and magnitude of A is equal to magnitude of B. इस केस में क्या होता है? E plus B is perpendicular to A minus B. Okay. Mod A plus B becomes equal to mod A minus B, becomes equal to A root 2. Okay. And alpha becomes equal to beta, becomes equal to 45 degrees. This is the special case of the square. So let's start today with some example questions based on application of this. So let's look at some application examples. So if E plus P is perpendicular to E minus B, and magnitude of E plus B divided by magnitude of E minus B is equal to 1 by root 3. Then find ratio of mod A is to mod B. Then the angle theta between vectors A and B. The angle alpha between the vector E plus B and the vector E. And finally, fourth part, the angle beta between E minus B and vector A. This question को बहुत ध्यान से करिए. The hint to you is you can do this question by both methods. You can use component algebra and solve it also, or you can make use of geometrical approach, and in that you can make use of the special theorem that we discussed. Just try this question out. Right. Kshitiz correct. Tulsi correct. Very good. Udit, you answer about the ratio is correct, but the angle you have to check. Okay, so one hint I will give you people if you want to. So I'm just giving you a couple of hints on how to solve this problem. So option one is you can solve geometrically. So geometrically, you see that given E plus B is perpendicular to E minus B, it means that the diagonals of the vector parallelogram are perpendicular to each other. तो उसका मतलब क्या है? That the parallelogram is a rhombus. Okay. So use rhombus properties. That's option one. Okay. And the second option is you can also try this by component algebra. So you can make use of component algebra method. तो उसमें क्या करो? Let E plus B is some xi cap. Okay, that is along x-axis. Therefore, since E minus B is perpendicular to A plus B, so you can take E minus B as some yj cap. Okay. Now solve using conditions given in the question. So that's another way of solving the question. So those of you who are still starting the problem, you have these two easy options of working it out. Okay. Meanwhile, no, yet to get the correct answer. Kanishk, your ratio is correct, but the angle theta unfortunately is not correct. Okay. So once again, just showing you the data of the question. Now try it out again by this method. Yeah, Kanish, answer is correct now for you. Tulsi, Rohini, unfortunately, it's not correct yet. So anyway, let me illustrate the first method of solving, the geometrical method. Then I will come back to the component algebra method of solving also. See, if you want to interpret this geometrically, the question में information क्या दिया हुआ है? It is given that E plus B is perpendicular to A minus B, and it is given that E plus B का mod divided by A minus B का mod is 1 by root 3. Or another way of expressing this is that mod of A minus B is equal to root 3 times mod of A plus B. If you notice here, what information we are getting from this, we are getting the information that the diagonals are perpendicular. That is telling us that it's a rhombus. The parallelogram is a rhombus. And the other information that I'm getting from here is that mod of A minus B is actually greater than mod of A plus B, because it's root 3 times. तो उससे मुझे क्या पता लग रहा है? Theta must be an obtuse angle. इतना idea तो पहले लग गया that theta will be some obtuse angle. So now let's try and visualize how the parallelogram must be looking. So it must be something like this. Must be this type. Theta must be obtuse. So that क्या हो रहा है? Is the secondary diagonal which is the longer one. The primary diagonal will be the shorter one. So theta has to be some obtuse angle, and magnitude of A has to be equal to magnitude of B. It has to be this type. Theta has to be obtuse, and mod A has to be equal to mod B. So that already gives you the answer to the first part, that magnitude of A is to magnitude of B. It will have to be 1:1. So hey, okay. But apart from that, let's see what else we can figure out. It's this type of parallelogram where, because it's a rhombus, you can see that the diagonals will be bisecting each other perpendicularly. And also another very important point is that the diagonals bisect the angles. They are angular bisectors of the sides. ये भी हमने property लिखा था rhombus का. So whatever the value of that theta is, it means that this angle alpha is the same as this angle alpha. So alpha will be equal to theta by 2. Okay. And likewise, यहाँ पे जो भी angle beta है, इसके बराबर होगा beta के बराबर. So beta will be equal to 90 minus theta by 2. You consider these right angle triangles, so that's there. Okay. So now the only thing is that we have to find theta, then we can find out alpha and beta also. Okay, so theta हम कैसे निकालेंगे? We will use this property that was given to us, that mod of E plus B upon mod of E minus B is equal to 1 by root 3. This is given. So suppose this side length is E, the magnitude of the vectors is E, B is equal to capital E. So now let us make use of this. So ये given information का use हम कैसे करेंगे? Mod of A plus B basically क्या है? It is root of A square plus B square, but here it will become A square plus A square plus 2A square cos theta, and mod of A minus B is similarly 2A square minus 2A square cos theta. So that is 1 by root 3. This is just like that sum we had done in exercise 4 also. अब इसको solve करना है. So A into square root of 2 plus 2 cos theta upon A into square root of 2 minus 2 cos theta is 1 by root 3. So square both the sides and you will get 1 plus cos theta upon 1 minus cos theta. In fact 1 by 3, or 3 plus 3 cos theta is equal to 1 minus cos theta. So as you can again see, you're getting cos theta as minus half. So that is telling you that theta is equal to 120 degrees. So cos theta is equal to 120, theta is equal to 120 degrees. It also means that alpha is equal to 60 degrees and beta is equal to 30 degrees. Okay. So ये आपके आंसर्स बन गए सेकंड पार्ट के और ये थर्ड एंड फोर्थ पार्ट के आंसर. So by just making use of the rhombus theorem, you can see you really simplified the solution a lot. Okay, hope this is clear, people. Okay, people, so hope this solution is fully clear. अभी देखो इसको ऑल्टरनेट मेथड भी मैं बताता हूँ, बट दैट इज थोड़ा सा इससे कंपैरिजन में लेंथी जाने वाला है. ठीक है, ऑल्टरनेट मेथड क्या है, दैट आई कैन यूज कंपोनेंट अलजेब्रा. So in this what we'll do is, since e plus b is given to be perpendicular to e minus b, मैं अब assume कर लूंगा, assume x axis is along e plus b, and by that end we can say that e plus b is some magnitude x I cap. Then it will imply that y-axis is along E minus B. So then we'll have to assume that E minus B is some unknown magnitude y, but along J cap. तो यहाँ से देखो अभी क्या हो रहा है. This means that magnitude of A plus B is x and magnitude of A minus B is y. Okay. So anyhow, now what we'll do is we will take this set of things as equation 1 and this set of things as equation 2. This whole information, this and this together, equation 1 and ये और ये equation 2. Okay. So you can see that you will get, if you add equation 1 plus 2, so left hand side में क्या मिल जाएगा 2a और right hand side में क्या मिल जाएगा x I cap plus y j cap. So that will give you that vector A is x by 2 I cap plus y by 2 j cap. The cap is unit vector, na beta? You see the I cap and j cap, the cap notation is unit vector. It is unit vector along x-axis, whereas the quantity over x over there is just a scalar. So this scalar multiplied by I cap becomes a vector. Similarly, y is just a scalar, but j cap is a unit vector which is specifically along y-axis. मतलब क्या है? It's a vector of magnitude 1 along the y-axis. That is the component notation method. Okay. So anyhow, now adding equation 1 and 2 from above, you can see. ये दोनों equations आप add कर दीजिए. This one, this equation is added with this equation. So left hand side में क्या आ जाएगा 2a. That right hand side में the sum of these two. That means a is this. And similarly, if you subtract the two equation 1 minus 2, तो a cancel हो जाएगा और left hand side में क्या आएगा 2b और right hand side में क्या आएगा x I cap minus y j cap. So from here you can see that the vector b will be how much? X by 2 I cap minus y by 2 j cap. So now you can see the first thing. From here I can now find the ratio of their magnitudes. So you can see that therefore magnitude of E is square root of x by 2 whole square plus y by 2 whole square, and magnitude of B is also the same. It is square root of x by 2 whole square plus y by 2 whole square, because whole square कर रहे हो ना, so minus sign doesn't matter. So this is showing you that magnitude of E is to magnitude of B has to be 1:1. This is giving you the first part's answer. And likewise, we'll find out the angle and all that also. So just make a note up to this first. So अगर आपने question को read करके geometrical वाला approach guess कर लिया है ना कि we can use the property of rhombus, then it is the easiest thing because you can directly make use of the special theorem of rhombus. But even if you have not guessed that, then you always have the component method to go back to. You can make use of component algebra and still come up with it's a reasonably easy solution, not as easy as the rhombus one, but it's still reasonably easy and you can solve it. ठीक है, आपको ये समझ में आ गया? नाउ हाउ विल वी फाइंड द एंगल थीटा बिटवीन ए एंड बी? फॉर दैट वी विल आल्सो हैव टू यूज द सेकंड इंफॉर्मेशन दैट इज गिवन टू अस. दूसरा क्या इंफॉर्मेशन दिया हुआ है? फर्स्ट तो ये था कि इट इज परपेंडिकुलर टू ईच अदर, बट अपार्ट फ्रॉम दैट ये भी तो इंफॉर्मेशन है अपने पास दैट mod a plus b is to mod a minus b. ये रेशियो कितना था? 1:√3 था. This was also given to us. So this information also we have to make use of now. So now see in equation 1 and 2 in magnitude form, mod a plus b कितना है? X है, और mod b minus b कितना है? Y है. So make use of this information. Okay. So next thing, making use of this information, we'll see that mod of a plus b is to mod of a minus b is 1:√3. That means x is to y is 1:√3, or x by y is 1/√3. That means मैं y को क्या सब्स्टिट्यूट कर सकता हूँ? x√3. Okay. So now using this, I will find out the angle between a and b. कैसे निकालूंगा अभी देखो. So now what I can do is I can draw the two vectors a and b because I know their components ratio now. So I can now think of drawing the vectors a and b in the xy plane, and they will look like this. So देखो अभी we'll end up drawing that rhombus on our own. So the vector E will become xi cap plus yj cap. So that will become how much? x√3 j cap. So vector A कैसा होगा? It will be making an angle of 60 degrees with the x-axis. This angle will be 60 degrees. How I know that? Because I know that ये जो perpendicular वाला side है इसका, ये y component होगा. So ये √3x होगा. और ये जो side है base है, वो कितना है? वो x है. Okay. Now similarly, what will the vector B become? The vector B was, sorry, this is x by 2y cap. There's also by 2, my mistake, plus y by 2. So ये x by 2√3 हो जाएगा. So just, but the ratio is the same. So the angle is the same. ऐसा हुआ. ठीक है. Now similarly, vector B क्या था वहाँ पे? It was x by 2 I cap minus y by 2 j cap. This we had already worked out earlier. See from here you are getting the vector E. Similarly from here you can see the vector B is becoming x by 2 I cap minus y by 2 j cap. तो यहाँ पे x को, I mean y को √3x से replace कर दो. So it become minus x by 2√3 j cap. So in the same diagram, where is your vector B going to lie? Vector B अब ऐसे होगा, ये वाले साइड में होगा 60 degrees. ऐसा कुछ होगा वेक्टर B. So that B का जो x component है वो सेम है x by 2, but y component जो हो रहा है वो कितना बन जा रहा है? minus √3 by 2x. So this angle is also 60. So now you can immediately see what is the angle between A and B. That is 120. So therefore theta is equal to 120 degrees. That is the angle between A and B. You can see ये वाला angle theta हुआ इस diagram में, ये angle. So that angle is the sum of these two. So that is becoming a second part. And now using this, we'll be able to separately calculate the third and fourth part, the angle alpha and beta. So as I told you, it becomes lengthy if you miss the geometry trick, which is why I told you that it's an important shortcut method. The special cases of parallelogram, कल हमने discuss ही किया था कि parallelogram law हम क्यों बनाते हैं, so that we can do the problems of these type of special cases very easily. Harshal, yeah, in principle it can come like that कि आपको एक ही particular method से ही solve करना है, but ऐसा question JEE में नहीं आ सकता ना, because JEE is your competitive exams are MCQ questions, they are computer based MCQ questions. तो आपको ऐसा question नहीं आ सकता है कि एक ही method से solve करना है. आपके ऊपर वो option रहेगा कि कौन सा method आप use करना है. बोर्ड्स में आ सकता है, but then ये क्वेश्चन बोर्ड्स के लेवल का नहीं है, ये क्वेश्चन बोर्ड्स के लिए ज़्यादा डिफिकल्ट लेवल है। बोर्ड्स में ज़्यादा आसान बेसिक टाइप के क्वेश्चन आते हैं, जिस टाइप के क्वेश्चन आपने पहले दूसरे लेक्चर में किए वेक्टर्स में, वो टाइप के क्वेश्चन ही इनफ है बोर्ड्स के लिए। बोर्ड्स के लिए आपको इतना ट्रिकी क्वेश्चन नहीं आने वाला है। देखिए, आप फिजिक्स केमिस्ट्री मैथ्स या फिजिक्स केमिस्ट्री बायोलॉजी जो आप यहाँ पे पढ़ रहे हैं आईटी सब में, उस ये सब्जेक्ट्स में आप बोर्ड्स के लिए कोई टेंशन मत लीजिए, क्योंकि जो आप पढ़ रहे हैं वो बोर्ड से काफी ज्यादा डेप्थ में है। जेई के लेवल के क्वेश्चंस का अगर आपने आधा भी सीख लिया है तो भी बोर्ड्स में आपको कभी कोई प्रॉब्लम नहीं आने वाला है। नाउ अगर आपने यहाँ तक लिख लिया है, नाउ ट्राई टू फाइंड द एंगल अल्फा एंड बीटा यूजिंग दिस। इट्स क्वाइट इजी, अभी ज्यादा डिफिकल्ट नहीं है, वो काफी आसान लगेगा अल्फा बीटा एंगल निकालना। एक्चुअली आंसर आपके सामने ही है, अल्फा बीटा है ना। आपको जस्ट सेम डायग्राम में देखना है कि a प्लस बी कौन सा वेक्टर है और a माइनस बी कौन सा वेक्टर है। ठीक है, सो सी कमिंग बैक टू दिस, हमने a प्लस बी को क्या लिया था, वी हैव टेकन इट एज x i कैप। सो लुक एट दिस स्टेटमेंट ओवर हियर, e प्लस बी क्या है, x i कैप है, और e माइनस बी क्या है, y j कैप है। सो कम बैक टू दिस डायग्राम ओवर हियर, तो ये डायग्राम में अब e प्लस बी कौन सा वेक्टर हो जाएगा, x i कैप। तो जस्ट कीप इन माइंड दैट e plus b is the vector x I cap. So it's very easy to understand ये diagram में where that vector e plus b is and what angle it is making. Okay. E plus b is x I cap. So that will become this vector here. E plus b अब ये वाला vector बनेगा. This is e plus b. So ये vector अब e के रिस्पेक्ट में कितना एंगल पे है? This is at alpha equal to 60 degrees with respect to vector e. Because the angle between these two vectors e plus b and vector a is this one, is 60 degrees. But and similarly मेरा e minus b vector कौन सा है? e minus b vector was y j cap, और that will become root 3x j cap जो भी है, but उसका डायरेक्शन क्या है, वो y axis के along है. So यहाँ पे वो वेक्टर कैसा दिखेगा, it will be like this, a longer vector but it will be like this. So this is your e minus b, which is equal to root 3x j cap. But more importantly, ये angle बीटा हो गया. So that is how much? That's 30 degrees. So it is at beta equal to 30 degrees with respect to E. So actually ये diagram में आपको rhombus भी दिख जाएगा ना. If you just look carefully, I'm just illustrating the point. Vector E आपका ऐसा था, vector B कैसा था? Little bit longer. Vector B ऐसा था. So vector E plus B अब ये बन जाएगा और E minus B ये बन जाएगा. This is your rhombus drawn this way. आपको दिख रहा है that E minus B वो इसके परपेंडिकुलर है E plus B के. Now this angle is 60. This angle is 60 and this angle is 30. आपको दिख रहा है theta is equal to 120, alpha is equal to 60, beta is equal to, because mod A is equal to mod B. So this is the same as that vector diagram. इसमें ये हमारा x axis था, ये y axis था. X and y axis like this and like this. That's how. So how we drew the vector E minus B over here, because it is y j cap ना, so it's along the y axis. क्यों y j cap था? Because हमने वही assume किया था ना vector को. यहाँ पे equation 2 में वही assume किया था. So that's how we are coming back to that same thing. ठीक है, समझ गए आप ये क्वेश्चन अब? So I'll take you through all the steps. एक बार फिर से देख लीजिए method 2. Okay, Mayank, it is clear beta now. Okay, good. Okay. So ये diagram जो देखे ना, that's the same as the one I've drawn. Same arrangement है, vectors a b, a plus b और a minus b का. Only thing is वहाँ a minus b को मैंने यहाँ पे draw किया था along the y axis. यहाँ पे ऐसे draw किया, but it's the same thing ना, they are the same vector. Okay, people. So hope this is clear. Now moving on to the next part of vectors. Component algebra, addition, subtraction, geometrical method, ये सारी चीजें हम समझ चुके हैं. Now the next thing we'll see is it's called scalar product of two vectors. Scalar product और इसका नाम डॉट प्रोडक्ट भी होता है. So this should not be confused with multiplication. इसका नाम प्रोडक्ट है, बट ये मल्टीप्लिकेशन नहीं है, बिकॉज मल्टीप्लिकेशन हम किसको करते हैं, स्केलर क्वांटिटीज को करते हैं. हम दो वेक्टर्स को मल्टीप्लाई नहीं कर सकते हैं. इंस्टेड उसके लिए हम डिफरेंट ऑपरेशन डिफाइन करते हैं, जिसको कि हम स्केलर प्रोडक्ट कहते हैं. ठीक है. सो स्केलर प्रोडक्ट को हम कैसे डिनोट करते हैं, द सिंबल यूज्ड फॉर स्केलर प्रोडक्ट और डॉट प्रोडक्ट इज अ डॉट. सो दिस थिंग ए और बी वेक्टर्स के बीच में अगर एक डॉट का सिंबल प्रेजेंट है, तो उसका मतलब हम क्या ऑपरेशन कर रहे हैं, वी आर कैलकुलेटिंग स्केलर प्रोडक्ट ऑफ वेक्टर्स ए एंड बी. दिस इज जस्ट द सिंबल और नोटेशन. दिस इज नॉट द डेफिनेशन येट. शॉर्ट फॉर्म में हम इसको ए डॉट बी भी बोल सकते हैं, बट बेसिकली इट मींस द प्रॉपर मीनिंग ऑफ इट इज दैट इट इज द स्केलर प्रोडक्ट ऑफ ए एंड बी. नाउ व्हाट इज डेफिनेशन ऑफ स्केलर प्रोडक्ट? Definition इसका होता है that A dot B is equal to magnitude of A multiplied by magnitude of B multiplied by cos theta. This is just a definition. ये definition कहाँ से आया, क्यों आया, that we will discuss later. That is not important for us just now. But definition क्या होता है, या हम कैसे calculate करते हैं A dot B, वो ये formula से calculate करते हैं. That it is just magnitude of vector A multiplied by magnitude of vector B multiplied by cos of the angle between them. So theta क्या है? It is the angle between vectors A and B. Okay. So पहले आप definition लिख लीजिए, then we'll discuss examples. जब हम इसके एप्लीकेशंस डिस्कस करेंगे, आपको क्लियर हो जाएगा कि क्यों ऐसे डिफाइन करते हैं. व्हाई इट इज ए बी cos थीटा, व्हाई इट इज नॉट ओनली ए बी, व्हाई इट इज नॉट ए बी sin थीटा. ये cos थीटा क्यों आता है वो हम बाद में समझेंगे. ओके, अभी यू जस्ट टेक इट एज अ रूल, एज अ प्रिंसिपल और एज अ फॉर्मूला दैट E डॉट B इज इक्वल टू मैग्नीट्यूड ऑफ A इनटू मैग्नीट्यूड ऑफ B मल्टीप्लाइड बाय कोसाइन ऑफ द एंगल बिटवीन देम, cos ऑफ थीटा बिटवीन देम. ठीक है people, written down the definition. It's just a formula और कुछ नहीं. ठीक है. So now let's understand some examples. So for example, अगर मुझे पता है कि वेक्टर E का मैग्नीट्यूड 20 यूनिट्स है, कोई भी यूनिट हो सकता है, सपोज डिस्प्लेसमेंट है तो मीटर है या किलोमीटर है, व्हाटएवर. B का मैग्नीट्यूड लेट्स से 40 यूनिट्स है, एंड इनके बीच का जो एंगल है थीटा, दैट इज 60 डिग्रीज. एंड आई आस्क यू कि हाउ मच इज E डॉट B? द आंसर इज वेरी सिंपल. E dot B will be given by the simple substitution of the formula. Definition से मुझे पता है कि ये E is magnitude into B is magnitude into cos theta होगा. So from here we substitute 20 units multiplied by 40 units multiplied by cos of 60 degrees, जो कि मुझे पता है half होता है. So ये 20 into 40 into half होगा. Now see, this is 20 units, this is 40 units, and cos theta is just a number. तो यहाँ पे इसका यूनिट फाइनली क्या आ जाएगा, वॉट एवर दिस यूनिट वाज उसका होल स्क्वायर. तो सपोज ये दोनों मीटर्स में थे तो ये मीटर स्क्वायर में आ जाएगा, लाइक दैट. सो फाइनली E डॉट बी कितना हो जाएगा यहाँ पे, E डॉट बी विल बिकम 400 units square. This becomes my final answer. Okay. Now similarly, suppose I had a situation, एक दूसरा एग्जांपल ले लेते हैं जहाँ पे given magnitude of E is 10, magnitude of B is, this time let's take a physical unit, suppose ये newtons में है, so E is a force vector, and B suppose meters में है, so B is a displacement vector because it's in meters. But इनके बीच एंगल जो है वो ऑब्ट्यूज एंगल है. Now I ask you that find E dot B. So here you will see E dot B interestingly will become a negative quantity because cos of negative cos of obtuse angle कैसा होता है, नेगेटिव होता है. So when I substitute, ये कितना हो जाएगा, this will become 10 newtons multiplied by 12 meters multiplied by cos of 120 degrees, जो कि कितना होता है, माइनस हाफ होता है. So ये 10 into 12 into minus half, और यूनिट क्या हो जाएगा, न्यूटन मीटर, जो कि आपको पता है जूल का यूनिट होता है, वर्क डन का यूनिट होता है. तो ये कितना हो जाएगा, माइनस 60 जूल्स हो जाएगा. इंटरेस्टिंगली ये जो आंसर आएगा मेरे पास, क्योंकि मैं फोर्स और डिस्प्लेसमेंट का स्केलर प्रोडक्ट ले रहा हूँ, तो वो एक्चुअली मुझे वर्क डन या एनर्जी का यूनिट देगा. तो ये एडिशनली यू कैन सी दैट जूल is the SI unit, standard international unit of work done or energy. So 1 joule is equal to 1 Newton meter. So that is why this is coming in joules. But more importantly, also note that E dot B is negative when theta is obtuse. So dot product दो वेक्टर्स का हमें एक नेगेटिव क्वांटिटी भी दे सकता है, like in this particular case. ठीक है. So now note down these two examples quickly. So there is nothing about dot product, है ना, आपको सिर्फ फॉर्मूला अप्लाई करना है, तो ज़्यादा डिफिकल्ट कुछ नहीं है. Okay, so done with this. Let's try out another question. Next example, the question is actually given in geometrical form now. XY प्लेन में सपोज मुझे दो वेक्टर्स ऐसे दिए हुए, दिस इज वेक्टर E, इसका मैग्नीट्यूड 15 यूनिट्स है. This is vector B. ये एंगल 60 डिग्री है, इसका मैग्नीट्यूड 12 यूनिट्स. सो फाइंड E डॉट B. नहीं, apply the formula correctly better. You have to also find out cos theta, where theta is the angle between them. आपको E dot B निकालने के लिए you need to know what is the magnitude of E that you know. It's 15 units. What is the magnitude of B? Okay, that you know, that's 12 units. But what about theta? ये भी तो चाहिए ना, because E dot B ये होगा ना. So what is the angle? Yes, Mayank, correct. What the correct answer? The angle between them, if I draw them more carefully, the angle between them will come out to be how much? 60 degrees. Because E vector कैसा है? E vector को अगर मैं origin से draw करता हूँ, ऐसा है ना? E was like this. Pick up this vector and draw it here. E angle 30 है, so that means यहाँ पे E angle 30 है. This is the vector E. I know 15 units. The vector E. और similarly vector B को मैं अगर origin से draw करूँगा, तो ऐसे हो जाएगा ना. Be something like this. इस लाइन के along था. In the above diagram, you can see it goes along this line, where E angle 60 था. तो यहाँ पे E angle 60 है. Okay. So if that angle is 60, you can see this angle is 30. So what is the angle between A and B? It is 60 degrees. So that cos theta will become half. So theta is 60 degrees. Okay. Therefore, E dot B is becoming 15 into 12 into cos 60. That is 90 units square. Okay. Vector B was like this. Supposed to. Draw it like this. Okay. All right. Now moving on. Some properties of dot product. So the formula being EB cos theta. So the first thing you have to understand is that dot product of two vectors results in a scalar quantity. That's why it's called is also called scalar product. Because you can see ना right hand side क्या है E dot B जो कि EB cos theta है. Okay. This is magnitude of a vector ना, so it's a scalar. This is magnitude of a vector, it's a scalar. और ये तो अपने आप में सिर्फ एक नंबर है. Magnitude of any vector is a scalar quantity. So it gives us a scalar quantity. Okay. So that is why in physics, definition of work done by a force F for displacement S. ये definition ही होता है that work done is F dot S. ये हम बाद में पढ़ेंगे एक चैप्टर में वर्क एनर्जी थ्योरम में. बट यहाँ पे देखो वर्क डन कैसा क्वांटिटी होता है. It's a scalar quantity. Okay. So dot product of two vectors gives us what kind of quantity? It gives us a scalar quantity. So that's the first aspect you must understand. इसका definition ही ऐसा है. It is magnitude into cos theta. So it's a scalar quantity. ठीक है, understood this point. Now secondly, one point we've already understood from couple of examples. If theta is acute, that is theta is less than 90 degrees, then E dot B becomes a positive quantity. On the other hand, if theta is obtuse, that is theta is greater than 90, less than equal to 180 degrees, then E dot B becomes a negative quantity. यहाँ पर भी it is greater than equal to 0, less than 90. And now very important special case, if theta happens to be 90 degrees, that is E is perpendicular to B, अगर वो special case है, then E dot B becomes 0. So इसका बहुत special significance है जो हम बाद में भी समझेंगे. Scalar product of perpendicular vectors is 0. If E is perpendicular to B, then the dot product is 0. So just note down this definition. ठीक है, so ये आपने लिख लिया. Now next thing, किसी भी वेक्टर का सेल्फ के साथ डॉट प्रोडक्ट becomes square of its magnitude, because very simple, because E dot E will be nothing but magnitude of E into magnitude of E into cos 0, and cos 0 is 1. And similarly, if you take dot product of any unit vector with itself, it becomes 1. Also, I cap dot j cap is 0, because they are perpendicular by definition. J cap dot k cap is 0. K cap dot I cap is 0. So this set of formula is also important to remember. Unit vectors के dot products, Okay, so make sure you remember these set of formulae, and इसका हम use अभी आगे भी देखेंगे when we look at dot products in component form. Okay. Next up, we'll see commutative property. That is E dot B is equal to B dot A. It is fairly obvious. And along with this, we will see the next one, which is distributive property. That E's dot product with the sum of two vectors can also be solved as E's dot product with the first one added with E's dot product with the second one. Okay. So note down these two important properties, please. Okay. So अब distributive property और commutative property का we will make use of them together to understand the next thing, which is the dot product in component form. How to calculate the dot product of two vectors given in component form. So for example, if there are two-dimensional vectors, vectors in 2D component form, then E dot B कैसे कैलकुलेट करेंगे? अब E को सब्स्टिट्यूट कर देते हैं यहाँ पे. So in component form, E is like this. Dot product with B को सब्स्टिट्यूट कर देते हैं. So in component form, B has got two components, Bx I cap and By j cap. Now this bracket can be used, opened using distributive property. So what property will make use of is distributive. Suppose we had something like this, E plus B dot of C plus D. So distributive property से मैं इसको कैसे लिख सकता हूँ? E dot B, sorry, E dot C प्लस E डॉट D प्लस B डॉट C, ऐसे 4 टर्म्स में इसको इंडिविजुअली ओपन कर सकते हैं, B dot D ऐसे. So that thing we'll do with this now using the distributive property. So this will become Ax into Bx I cap dot I cap plus Ax into By I cap dot J cap plus Ay into Bx J cap dot I cap, and fourth and final term Ay into By, but J cap dot J cap. Okay. Now we will go back to what we learned about unit vectors earlier. ये वाले formula. Go back to these formula, and you'll realize कि I dot I is 1, J dot J is 1, but I cap dot J cap कितना हो जाएगा 0. J cap dot I cap कितना हो जाएगा 0 हो जाएगा. So making use of that over here, making use of the fact that I cap dot I cap is 1, J cap dot J cap is 1. So ये वाला term और ये वाला term कितना हो जाएगा, unity हो जाएगा. Whereas on the other hand, I and J are perpendicular to each other, so I cap dot J cap is 0. Commutative property, J cap dot I cap, yeah, 0 because they are perpendicular. So this term and this term, they will become 0. So finally, substituting that, what we are left with a very simple formula. It becomes Ax into Bx plus Ay into By. So this Ax into Bx multiplied by 1 plus ये second term 0 हो जा रहा है, ये third term 0 हो जा रहा है, plus Ay into By multiplied by what? 1. So this becomes the formula. So two-dimensional component form में we can directly apply this formula to find E dot B. इतने सारे स्टेप्स हमको हर बार करने की जरूरत नहीं, ये सिर्फ फॉर्मूला समझने के लिए था, बट नाउ वी नो दैट दिस इज अ डायरेक्ट फॉर्मूला. जैसे इन ज्योमेट्रिकल फॉर्म वी राइट इट एज AB cos theta, so like that in component form in 2D it becomes this, it becomes Ax Bx plus Ay By. Just make a note of this so far, then we will come to 3 dimensions also. Okay, so let's do a couple of questions now based on this. So for example, अगर वेक्टर A ऐसा है 2i cap plus 4j cap, और वेक्टर B ऐसा है I cap plus 2j cap, then E dot B कितना होगा? So all we have to do is directly substitute in the formula here. E dot B will be Ax Bx plus Ey By. So that will be 2 into 1 plus 4 into 2. So 2 plus 8, 10 हो जाएगा. Now similarly, if we have an example where now this is where we have to be a little careful. अगर ऐसा कुछ है 2i cap minus j cap and vector b is suppose 3i cap plus 4j cap ऐसा कुछ. Okay. Now when we are calculating a dot b, we have to understand that algebraic sign becomes important. So this is 2 into 3 plus minus 1 into 4 हो जाएगा. because यहाँ पे देखो a के components क्या है? They are 2 and minus 1. B के components क्या है? 3 and 4. So substitute accordingly. So this will not be 10. This will instead be 6 minus 4, or this will be 2 in this case. So just make a note of these two examples, please. All right. Now next, let us understand dot product when vectors are given in three-dimensional components. So if E is expressed in terms of all three components, x, y, and z component, and D is also expressed in three-dimensional component, then again we have to do that same kind of operation, but you'll realize this time when I open these brackets with distributive property, तो total मेरे पास कितने terms आ जाएंगे? 3 terms into 3 terms, so there will be 9 terms. But 9 terms में काफी सारे terms zero हो जाएंगे because dot product of unit vector with a perpendicular unit vector is how much? It is 0. So you'll see that 6 of those 9 terms will become 0 and only 3 terms will remain. So next step, when you open this bracket, you will have ax bx going with I cap dot I cap plus ax by with I dot j. Now ये term कितना हो जाएगा? 0 हो जाएगा because I dot j is 0. Similarly, the third term ax bz, ये term भी कितना हो जाएगा finally because it is I cap dot k cap. So ये term 0 हो जाएगा. Then the next term is ey dot product with the 3, so ey dx. But वापस ये क्या होगा? 0 हो जाएगा because j dot I is 0. ey by, this term will remain because j cap dot j cap is unity, and this term again ey bz will get multiplied by 0 because j cap dot k cap is 0. And similarly, the last term here ez dx, ये भी 0 हो जाएगा because k dot I is 0. ez dy, ये भी 0 हो जाएगा because k dot j भी 0. But last term जो है ez into bz, this term will survive because this is k cap dot k cap, which is 0. Okay. So next step, when we are going to solve this, we will make use of the fact that I cap dot I cap, j cap dot j cap, and k cap dot k cap, these सारे terms 1 होते हैं, whereas I dot j, j dot k और k dot I, ये सारे terms 0 होते हैं. So ये term, ये term, ये term, ये term और ये दोनों term ये 0 हो जाएंगे. Whereas कौन से terms बच जाएंगे? ये 3 terms, this and this will survive. Okay. So ultimately what we will get very similar formula to the 2-dimensional case, one extra term ax bx plus ay by plus now product of the z components. So ये मेरा formula बन जाता है for the dot product of two vectors when they are expressed in 3D component. Okay, so just make a note of this. So let us look at some application examples. Okay, just try these three examples. Okay, so got the answers, people? Yeah, correct. Kanishk, your answer is correct. Udit, correct. Rohini, correct. Guranch, first part is correct. So इस केस में a dot b will become 1 into 2 plus 2 into 3 plus minus 1 into 2. So now we get 2 plus 6, 8 minus 2, 6. So it becomes 6. That's the answer for the first one. A dot b will be 6. Now secondly, in this one, ये वाले केस में it will be 1 into 1 plus 1 into minus 1 plus 1 into 0. 0 होता है. So ये वाले केस में e dot b will be 0. And similarly, third case में it become 1 into 0 plus 2 into 1 plus 0 into minus 1. So it's just becoming e dot q. So ये आपके आंसर है. So very simple, as you can see, calculating dot product by in both cases is very simple. Whether it is geometrical method because the vectors are given in in magnitude and angle, or it is the component algebra method because the vectors are given to us in component form. जो भी हो, ultimately formula ही use करना और कुछ नहीं. Okay, so we're almost done. Now, just one final thing you have to understand. So this is very important, like an application of dot product. So since cos 90 is equal to 0, therefore the condition for two vectors to be perpendicular is that their dot product should be 0. So for example, if we have a question like this, that vector E मुझे दिया हुआ है I cap plus 3j cap plus 4k cap, और vector B मुझे दिया हुआ है 2i cap minus j cap, but plus some z k cap, where z is an unknown quantity. We want to find z if A is perpendicular to B. Now we want to do a question like this. तो यहाँ पे हम ये वाला concept use करेंगे. That condition for perpendicular vectors is that dot product is 0. So that is the idea we'll apply in this question. So what we'll say is that, okay, if the vectors are perpendicular, E is perpendicular to B, implies that A dot B should be 0. So further, that implies that 1 into 2 plus 3 into minus 1 plus 4 into z should be 0. The ax dx plus ey by plus ez dz should be 0. This implies this. So यहाँ पे this becomes 2 minus 3 plus 4z is equal to 0. So that means z is equal to 1 by 4 or 0.25. So this becomes the answer. So this is the sort of simple application of dot products being 0 for perpendicular vectors. Okay, people. So this question is clear and this application is clear, right? So with that, we conclude today's lecture. Okay, so now we are done with the basics of dot product or scalar product. So in vectors now only one operation is remaining, which is cross product. But we will take at least one more lecture to understand some more applications and methods of in which dot product is used to calculate different things. So though we have learned how to calculate dot product, but uske applications kaise karne hain, that will take one more lecture, and after that one or two more lectures to understand cross products and its application, and that will complete the vector engine. Okay, so after today's lecture, I'll be sending you a couple of worksheets because last lecture's worksheet is also pending. So this week you will have double the number of worksheets. You'll have worksheet number 5 and 6. Now 5 will be like a revision worksheet. It will be just basically application of the things that we learned before dot product, whereas worksheet 6 will have the application of dot product. So I'll send it to you in the group along with the PDF notes and everything. Okay, thanks for attending, people. That's it for today. Bye then, and all the best.